Okay. Reg, hierdie is, jy kan sien na bo, dit sê graad 12, Physical Sciences, grade 12, chapter 9. So, jy moet nie die hoofstuk weggooi nie. Okay, because from page 1 to page, to page 8 is grade 11 work. So, jy skryf nou, you write now, from page 1 to page 8. From page 9, wat sy 9 af aan, is graad 12 werk. Okay, maar dit skryf jy nie nou oor nie. Okay, so die juffrou wat kom, gaan dan aangaan met hierdie werk. So you only write until page 8. This is a copy of grade 11 and grade 10 notes. So as niks dit behoort bekend reg te lyk. What we have on page 1 is just some definitions that you need to know. Paar definisies wat jy moet ken. Okay, so let's look at a few of them. Conventional current direction, konvensionele stroomrigting, that you know is from the positive side. Bonjour. Van die dis positiewe ladingkies wat vloei van die positiewe na die negatiewe pol van 'n battery. Dis in 'n stroombaan. This is not something that they ask a lot. Then elektriese potentiaalverskil, electrical potential difference. This is something that you did in grade 10. Okay, wat hulle nou en dan vra, they don't ask it that much, but they do ask it. Nou hierdie definisie, energie oorgedra, energy transferred per unit charge, kom van hierdie formule af. Okay? So energy of potential difference in energy per unit charge. Remember, W stands for work. And work is measured in joules. What else is measured in joules? Energy. Okay. So energie and work, of in Afrikaans arbeid. En dan Q staan obviously vir jou lading, your charge. Okay, so dis waar hierdie definisie vandaan kom. Alright. Dan die volgende, the next one is the definition that I do ask a lot. So the next one is the definition that they ask a lot because it links with your grade 12 work. Okay, so hierdie oorvleuel met jou graad 12 werk. So hulle vra vir die EMK of die elektromotoriese krag, electromotoric force. Okay, then only the first part is your definition. It's the maximum energy transferred, die maximum energie oorgedra deur 'n battery per coulomb lading. Okay, so in your kop, in your head, what is the EMF? It is the volts over the battery, the terminals of the battery, if no charges pass through it, or in your head, it is the maximum volts. Okay, nou, ek weet nie of jy kan onthou my toebroodjies, my sandwiches, and the little men walking through the circuit, blah, 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 blah. En toe het ek nog laas jaar, we said, we're going to pretend it's the perfect world where you go home and you get 10 more sandwiches. En dan hierdie jaar het ons gesê, we know life is not perfect. You get home and it's yap, and you need some energy for your situation at home. Okay, so dit is waar die verskil inkom. So EMK, EMF is your maximum volts, your maximum sandwich, your maximum amount of sandwiches that you have. Okay. Right. Then we have something called terminal potential difference. Nie iets wat hulle so baie vra nie. They don't ask it that much. What is terminal potential difference? That is the potential difference over the terminals of the battery if there's a charge that flows. So dit is nie jou maximum nie, maar dit is jou the rest of your volts. So dis die toebroodjies wat jy skool toe vat. The sandwiches that you do take home. Ag, not home, to school. Goed. Then we have current strength, stroomsterkte, definisie wat jy al goed moet ken. That is, so the definition is just that first part, is the rate of flow of charge. As jy hoor tempo, waar moet jy dink? Tempo is gedeel deur tyd. Rate is divided by time. So how fast the charges moves through the circuit. Then we have electrical charge. Elektrische lading word gemeet in coulomb. Sorry, hierso wil ek net sê, hierdie word gemeet in ampere, né? This word gemeet in coulomb. These are things I think you know. Stroomsterkte is in ampere, amps. Lading is in coulomb. Resistance, weerstand word gemeet in ohms. Okay, ek dink daar is nog iets oor potentiaalverskil. Potential difference is measured in volts. Okay, so there are a few definitions that you should know up until now. Enige vrae daar, enigiets wat ek moet deurgaan of weer verduidelik. Okay, volgende bladsy. Right, then in grade 11, the thing that came in grade 11 from grade 10 is Ohm's law, Ohm's wet. Okay, nou, hierdie is een van die praktiese wat ons sou kon doen. We could have done this practical this year, but I chose to do the acids and bases practical rather with you guys. Hoe het dit gegaan? Was dit lekker?
Oh, dit is lekker.
Nee. I think look, it's just a nice practice. I'm sad I was not here, but anyway, so I chose to do that practical, not this practical. Ohm's law practical is not difficult at all though. It's where you would have used a rheostat, like your volume button on your music or your dimmer lights or something like that. So rheostat gebruik het and you would have changed the resistance and then you'd have seen how it affects the volts and the current. Okay, so dis nie so you see the light bulb go dimmer and not dimmer. Bietjie boring. Okay, goed. What does Ohm's law say? Definition here that you should know, like I mentioned, this was new in grade 11. You write until grade 11. So, jy neem aan Ohm's wet gaan hulle heel moontlik vra. What is Ohm's law? It's the potential difference over a conductor, oor 'n geleier, is direk evenredig, directly proportional to the current in the conductor at a constant temperature. Okay, nou hierdie konstante temperatuur is die deel wat belangrik is, because if the temperature of the conductor increases, then the resistance also increase. Okay, so jy wil hê die temperatuur moet konstant bly. Hoekom? Because if the temperature remain constant, then it means the resistance is also constant. Okay, so dis waar ons aan 'n formule daar aan die regterkant kom. When we get to this formula here, where R is the resistance, V is the volts, and A is the current. Okay, so ek sê onder vir jou, I've mentioned this now, if the resistance increases, the temperature increases as well. And then if we keep that constant, then we can say that the current is directly proportional to the potential difference. So as die weerstand konstant bly, dan is daai twee direk evenredig aan mekaar. Okay, so on the right hand side here, I have two graphs. Ek het twee grafieke. They are just inverses of one another. So hierdie is stroom teenoor potentiaalverskil, and this one is potential difference versus current. So they're the same graph, the axes are just swapped around. Want in this practical, normally where does the dependent variable go? Die afhanklike veranderlike. So die y-as depends on the y-axis. In this experiment, it's the one experiment where they swap them around. The dependent goes on the x-axis. En dis hoekom ek twee grafieke hierso het om net vir jou te wys. Hulle gaan eintlik vir jou dieselfde ding gee. They give you the same thing. Let's quickly look at. I first want to look at the second graph. As jy hierso kyk, there you can see we have volts versus current. Onthou volts is obviously in volts en stroom is in ampere. When you get a graph, what's the first thing you ask yourself? What does the gradient tell me? Die gradiënt is altyd die verandering in y oor die verandering in x. And for this one specifically, it would have been volts over current. And if you have volts over current, what do you get? That's the same as resistance. Okay. Weerstand. So what you get here basically is you see that you get a straight line. You see you kry 'n reguit lyn. So it means we have a constant gradient, which means we have a constant resistance. So indien hulle vir jou, if they give you a graph like this, okay, so they give you this, and they have done that in the past, they give you so grafiek, and then they ask you, determine the resistance that is used, bepaal die weerstand wat gebruik is. Then you need to know, okay, they want the resistance, and eintlik net die gradient gaan uitwerk. I'm just going to calculate the gradient for this graph. Okay, dan as ons kyk na die grafiek hierbo, and the graph at the top is the one that more or less you would have done in your practical. Okay, 'n stroom teenoor potentiaalverskil. So again, if you ask yourself, what does the gradient tell me? Then here we have, it is the current versus, current over volts. Okay, ons het nou net gesien, we just saw there at the bottom, that resistance is volts over current. So that is the inverse of that. Hulle is omgekeerd is van mekaar. So dit is die resiprook, dat is 1 oor R. Okay, so most of the time they like to ask this graph here. En dis hoekom ek hom eers daarbo gesit het ook. Because they'll give you a graph like this, and then they'll ask you determine the resistance. Gaan bepaal die weerstand. Then you will go determine the gradient, and then you'll take the inverse of the gradient as the resistance. Okay, maar ons gaan so 'n voorbeeld doen. Enige vrae, any questions, something I must repeat there. Okay, so as ons net gou kyk, ekskuus, nog iets wat ek wou sê, if you get a straight line like this, reguit lyn, then we say it is an ohmic conductor, 'n ohmiese geleier. Okay, 'n ohmiese geleier. So it will give you a straight line, dit gaan vir jou 'n reguit lyn grafiek. And what is an ohmic conductor? One that obeys Ohm's law. Nog steeds juffrou, wat beteken dit? Dit beteken net die temperatuur bly konstant. That just means the temperature remains constant. So if we say something is an ohmic conductor, dan sê sy die temperatuur het konstant gebly. Okay. Now you can make two types of conclusions. The first one is a graphical conclusion. For graphical conclusion, what do you look at again? You look at the shape of the graph. Jy kyk na die vorm van die grafiek. Okay, you will normally get one of two shapes. You will either get a straight line like that, or you'll get a curve like that. Dis die twee vorms wat jy gaan kry. Het jy gesien dat jy 'n reguit lyn gekry? Okay, so for a straight line graph, we can say that y is directly proportional to x. A is direk evenredig aan x. Okay.
En jy ook dan aanneem dat die weerstand kan afleid en die temperatuur dan ook dus.
So dis die afleiding wat jy gemaak by die algebraïese afleiding. Alright, I want to look at, let's label this graph 1 and this graph 2. Let's say we're going to look at graph 2. Ek gaan na grafiek 2 kyk. Okay, so for graph 2, we have on the y-axis, we have volts, and on the x-axis, we have current. So ons kan sê volts is direk evenredig aan stroom. So that will be our graphical conclusion. Okay, now, they can ask you, write a conclusion for this graph. Okay, nou ek het vroeër die jaar dit al genoem. I'm going to say this again. When are you allowed to use directly proportional? When there's a formula that goes with it. Okay, so hier mag jy gebruik. Here you are allowed to use the words volts is directly proportional to current. Okay, if there's not a formula, as daar nie 'n formule op jou datavel is wat daarmee saamgaan nie, then you're not allowed to use the words directly proportional. Then you must say as the one increases, the other one increases. Okay, dan ook, wanneer jy dit sê, when you say that directly proportional, something must remain constant. So jy sê, dit is direk evenredig aan dit, at a constant blah blah blah. So hierso gaan jy sê, that is directly proportional to each other at a constant temperature. So iets moet konstant bly. Okay, then a algebraic conclusion is where you're going to look at a formula or an equation. Okay, so for a straight line graph, vir 'n reguit lyn grafiek, ek weet julle skryf wiskunde wanneer? Vrydag. Thank you. Y is equals to mx plus c. Okay. Now here, this is where in your grade 12 work, it gets a bit complicated. The teacher will explain that to you. Maar waar hy bietjie moeiliker gaan raak. Okay, but for now, your C will be where it crosses the origin. Okay, so for now, in graad 12 werk verander dit bietjie, but for now, your C will be 0. It will go through the origin. Ek gaan deur die oorsprong gaan. Op die y-as het ons volts, gradiënt soek ons, die x-as is stroom, plus 0. And then we get the gradient is volts over current. En ons sê is goed, van daar af, from there we can thus say the gradient is the resistance. Okay, so wat hulle dan in graad 12 gaan doen is they will give you a formula and a graph and then they'll say go determine the internal resistance. En dan gaan jy goedjies van die grafiek hier moet gaan insit waar dit is. So die wiskunde kom. Okay. Then what is a non-ohmic conductor? It's a nie-ohmiese geleier. That is obviously one that does not obey Ohm's law. So the temperature or the die verhouding bly nie konstant nie, of die weerstand of die temperatuur bly nie konstant nie. The resistance or the temperature does not remain constant. And an example that we have there, or a good example, is a light bulb. Hy word warmer en warmer en warmer en warmer en warmer. Okay, and here you can see the graph that we have. It makes a curve like this. So this is a multiple choice type of vraag. They'll give you a few graphs and they'll say which one represents a non-ohmic conductor. Okay, dan moet jy weet as hy 'n kurwe maak, nie ohmies. Goed. Kom ons kyk gou vinnig. Hier is graad 10 werk, grade 10 work about circuits and the calculations that we do. Okay, dan gaan ons nou 'n bietjie moeiliker na graad 11 werk doen en dan is dit klaar. Okay, so here we have a circuit in series with one another. Jy haal vir my 2 of 3 highlighters uit. Please, in a test, redraw your circuit. Jou stroombaan gaan nou moeilik word. Dit gaan inception wees, soos 'n weerstand binne in 'n weerstand, binne in 'n weerstand, binne in 'n weerstand. Okay, so you need to highlight. Okay? First of all, we can see here that the current is the same everywhere. Die stroom is oral dieselfde. Hy split nie op nie. So the current is the same everywhere. Die stroom is oral dieselfde. Excuse. And then if we look at our sandwiches or stoebroodjies. Then this is as if we have 3 periods for the day. So vir vandag het jy toets geskryf, you wrote exams, and then you had 2 science extra classes, 2 hours of science extra classes. So jy moet jou toebroodjie opdeel in, your energy, your sandwiches, you must divide up into 3. So let's say you had 6 sandwiches, 6 volts. And let's say the resistance are equal. Kom ons sê die weerstand is almal dieselfde. Then it will split up 2, 2 and 2. Okay, remember they'll only split up 2, 2 and 2 if the resistance are the same size. Nee, hulle gaan nie altyd evenredig opsplit nie. Goed, so we say there that your volts will divide up, or it will split up. So we say resistors in series are potential dividers, potentiaal verdelers. Okay, and as jy jou totale weerstand moet gaan uitwerk, then you're just going to add them together, because they are in series with one another. Ek gaan nou redelik vinnig hierdie rond, ek dink jy ken hierdie. Kyk, ons kyk net gaan na 'n voorbeeld hierso. Hulle sê bepaal die lesing op die ammeter. So I'm just going to take my highlighters first and say, right, so the little men walk, they have to walk through the 2 ohm and the 4 ohm and the 12 ohm. Okay, so die stroom is oral dieselfde, the current is the same everywhere. Then they have to walk through the ammeter. So the ammeter measures the total current. Hy meet die totale stroom. Okay, then for the day I have 6 sandwiches. Vir die dag het ek 6 toebroodjies. Okay, en dis asof ek het, I have aloe, and then I have Afrikaans, and then you have maths. Okay, so jy moet jou toebroodjies opdeel, bietjie gaan soontoe, bietjie gaan soontoe, bietjie gaan soontoe. Will your sandwiches divide up 2, 2, 2? Nee, want jou weerstand is nie dieselfde nie. Okay, right, so they ask you there, determine the reading on the ammeter, and the ammeter measures the total current. Okay, so in my info tabel, they want the total current. For that, I need the total resistance and the total volts. You'll see in past papers, and ou vraestelle, they do not use these footnotes, hierdie subscripts, total. That's something that I do. You can do it. Dit help my dat ek dit groepeer, because otherwise there's a lot of values floating around. Okay, die total volts is maklik. Daar is dit 6 volts, so 6. The total resistance will be what? Yes, 18, want dis 2 plus 4 plus 12 geef jou 18. Okay, you do not need to show this in a test. Jy is nou al graad 12. I'm just doing it for completion's sake. 18. So, if you have to go determine the current, onthou jy skryf 'n formule neer presies soos wat hy op jou datavel is. Then you substitute the values. And then you rearrange and you kry 0,3333 ampere. Alright, any question there? Juffrou, hoekom, wat, waar? Niemand. Volgende bladsy. Okay, so ons kyk na parallel. We look at parallel. Okay, hierso loop my mannetjies. I see everyone needs to pass through there, so that measures the total current. En dan het my mannetjies opsplit. Then my little man needs to split up. Okay? Some of them go through there, some of them go through there, some of them go through there. And I'm going to take the values from the previous page, die waardes van die vorige bladsy het ons gehad. Die ene was 2, ek dink 2 en 4 en 12. Ja. 2 and then 4 and then 12. Okay, goed. So, kom ons sê, and let's say you have your sandwiches that you walk there from home is again 6 sandwiches. Alright, Johan, hier loop jy. Voor, wat was hierdie gewees? L. Hoeveel toebroodjies het jy? 6. En na L? Waar kom jy aan 4? Hierdie 6 is volts, hierdie 2 is ohm. Ek kan nie ohm en volts van mekaar aftrek nie. Okay, onthou ohm. Gaan ek hier maak. 2 ohm is hoe moeilik dit is. The difficulty rating. Okay, and that volts is your energy, your sandwiches that you have. So, twee verskillende konsepte. Okay, so after, he walked through the register. Then Miss Phsc checked, he has 6 sandwiches. After Allo, he goes directly home where he gets 6 more sandwiches. Mag jy met toebroodjies by die huis opdaag? Nee. Okay, so jy moet al jou toebroodjies opeet. So hoeveel het jy daar? 0. Okay, why 0? Because after that he goes directly home. So that voltmeter reading will be 6 volts.
For all of them will be 6 then, hè?
Hy spring voor, ja. Okay, Cindy, hier loop jy. Van die huis af. Jy gaan nie Elwe toe nie. Jy het gekies om Afrikaans toe te gaan. Okay, so you can see I asked someone else, meaning it's a different charge. It's a different choice. It's not the same particle. Okay, so ander ene, other particle goes here. Voor Afrikaans, hoeveel toebroodjies het jy? Na Afrikaans, hoeveel toebroodjies het jy? Hoekom? Want jy moet al jou toebroodjies opeet, want jy gaan reg uit huis toe. So this is again 6 volts. Alright, Chantay, jy kies wiskunde, jy loop jy, voor wiskunde, hoeveel het jy? Na wiskunde, hoekom? Jy gaan direk huis toe. Remember, from here, you can't go back into the current. Okay, you have to follow the current. So this is again 6 volts. So what I want you to what I wanted to show you here, and what you must remember, is that in parallel the volts are the same. So it's not 6 plus 6 plus 6 gives you 18. Okay, dis nie jy tel hulle nie by mekaar nie. Die volts in parallel is dieselfde. En dis is different mannetjies, verskillende mannetjies. Okay, so we can see here that the volts over each branch is the same. But what we did see is that the current splits up. Die stroom split op. Okay, so we could have seen here, some went through there, some went through there, some went through there. So die stroom, die hoeveelheid mannetjies wat jy daar het, hulle split op. Okay, and if you have to add your resistance together, parallel, you do it in this weird manner. Okay, because you do not have to go through each of them. Jy hoef nie deur elkeen te gaan nie. You have a choice, so it gets easier. You don't have to choose science and business and tourism. You can choose between them. Okay, so dit maak dit makliker. Daar's iets wat ek wou sê. Okay, alright, so, a question, a theory question. Let's say we have this, let's say we have, so this is a multiple choice type of question, where we have, oh man. Okay, we have a circuit like that. This is stroommaan daar, parallelle stroommaan. And let's say all the resistors are, all the light bulbs are equal. Al die gloeilampe is dieselfde. They'll say they're all equal. They will not give a value. So dan maak jy 'n waarde op. Sê nou maar jy sê 2 ohm, 2 ohm, 2 ohm. Of 1, 1, 1. Of wat ook al, 10, 10, 10. Right. How will the total resistance be affected if we add another light bulb in parallel? Hoe gaan die totale weerstand geaffekteer word as ons nog 'n gloeilamp in parallel sit? Increase, decrease, or remains the same? All in favor of increase, put up your hand. All in favor of decrease, put up your hand. En die res van julle kry nou sweetie. Decrease. Oh, hierdie sweeties is klein, maar. Alright, hy gaan afneem. Hoekom? If we look here, excuse. If I look at just this one. Okay, so opsie 1. 1 over r parallel will be 1 over 2 plus 1 over 2 plus 1 over 2. That gives me what? I'm waiting for 3 over 6. 3 over 6? Sê jy ja? Ja. Okay. 3 oor 2, nee? And remember, then you must show that you swap them around. 3 over 2, en dit gee vir my 1.5. How do you know 1.5 is more or less on the right path? Dis kleiner as die kleinste een. 1.5 is kleiner as 2, sharp. Now I tell you, we add another one in parallel. Okay? So now het ons 1 oor 2 plus 1 oor 2 plus 1 oor 2 plus 1 oor 2. Ag man, ja. Wag, ja. Man, julle. 2 op 3. Jy is 100% reg. 0,67. Nee? Ja. Dankie. All right. I'm going to say again, so now in the second scenario here, what did we do? I said, what will happen to the resistance if we add another resistor in parallel? Okay, so dis hoekom ek nou 4 het daar, that's why I have 4 there. So that gives you, what's that, 4 over 2. That is 2 over 4. En dit geef jou half. Okay, so can you see that what happened there is the resistance decreased. So if you add more in parallel, then the total resistance decreases. Nou my vraag, en as jy steek jou hand op, dan kry jy 2 sweeties. If we add another one in parallel, how will the total current be affected? Hoe gaan die totale stroom geaffekteer word? Ja.
Die totale stroom
gaan dan?
Hy gaan meer.
Yes, hoekom?
Want jy plus hulle bymekaar.
Nee.
En dan word elke keer as jy een van hulle wys, so dan is daar nog 'n opsie van om te vat en dan as jy met bymekaar sit dan word dit meer.
Jou gedagte maak sin nou, maar dit gaan nie altyd sin maak nie.
Ja.
Alright, so I asked, my question is, what will happen if we add more? What will happen to the current? Okay, for that, I'm going to zoom in on the right hand side. For that, you're going to go back to Ohm's law. Okay, when we added more resistors, did we change the volts? Nee. So jy gaan sê die volts bly konstant. The volts remain constant. Something must always remain constant. Okay, die volts het konstant gebly. Okay. Then we can see that the current is inversely proportional to the resistance. Die stroom is omgekeerd evenredig aan die weerstand. What happened to the total resistance from there to there? The resistance decreased. So what's going to happen to the current? The current is going to increase. Okay, so the total resistance decrease, so that is why the total current will increase. Okay, and this is a typical grade 11 theory question. Typies.
Dit is 'n series, is dit ook so? Kan mens ook dit
Ja, maar is bietjie makliker, né? Nee? Want as jy nog een in serie insit, wat gaan gebeur met totale weerstand?
Dit gaan net dieselfde bly.
Nee.
Ekskuus, die stroom bly dieselfde.
Nee. Okay, so dis nie so maklik as wat ek gedink het nie. Kom ons kyk gou hier. So, let's say right? So, from there, if we add another one in series, what's going to happen to the total resistance? It's going to increase, né? Because ons dink is obvious, maar kom ons maak net seker. 2 en 2 en 2 en 2. So in the first scenario, the total resistance would have been 6. Want jy plus dit by mekaar. In the second scenario, when you add another one, the total resistance would be 8. So the total resistance increase, dan weer eens, current is inversely proportional to resistance, so that is why the total current will thus decrease. Okay. Uitgedink, nie, hulle het dit ontdek. Okay, goed. Going. Not gone. Gone. Okay, alright. Let's quickly look at this scenario here. It says, consider it and then determine the reading, blah, blah, blah. So, kom ons gaan eers highlight. Hier gaan my mannetjies. Do. Ek sien almal gaan deur daai ammeter. Okay? So that ammeter measures the total current. Then the current splits up. Dan gaan die stroom opsplit. Bietjie daardeur, bietjie daardeur, bietjie daardeur. Okay, so it's like you have allo or a double maths or one science. Okay, so jou stroom gaan opsplit, but each man walks with 6 sandwiches. Elke mannetjie loop met 6 toebroodjies. So the one that choose to go to allo has 6 sandwiches. The one that choose a double maths have 6 sandwiches. The one that choose one science has 6 sandwiches. Okay. Nou, Taskia, waar voorspel jy gaan die grootste stroom wees? Deur watter tak? Hoekom? So jy dink omdat daar 2 goeders is, gaan daar groter stroom, aka meer mannetjies hierdeur gaan. As jy 'n keuse het oor watter periodes jy kan doen die dag. Jou keuse is of LW en dan gaan jy huis toe, of dubbel wiskunde en dan gaan jy huis toe, of een wetenskap en jy gaan huis toe. Waar gaan die meeste mense gaan? LW en dan gaan jy huis toe. So, we predict that because this is the smallest resistance, the bigger current will go through there. En omdat hierdie die grootste weerstand het, the biggest resistance, the smallest current will go through there. Okay, sharp? Yes. Okay, kom ons kyk gaan na die vraag. Sê, calculate the reading on the ammeter. Where's the ammeter? There's it. It measures the total current. Jy gaan bladsy hierso in 2 opdeel. Okay, so they want the total current. For that, we need the total resistance and the total volts. Menai, wat is die totale volts? 6. Is dit nie 6 plus 6 plus 6, 18 nie? Nee. 6, klaar. Daar's wat sit? Nee, daar's nie nou 6 mannetjies nie. Elke mannetjie het net 6 toebroodjies. Okay. Else, for the total resistance, can I say 2 plus 6 plus 6 plus 4? No, why not? Then parallel. So you have to do the weird parallel thing. Lepelo, how many branches are there? 3 branches. So you are going to say 1 over 2 plus 1 over 12 plus 1 over 4. You have 3 branches, so you have 3 fractions. 3 takke, 3 breuke. Okay, where do I get to this 12? Onthou hierdie is 6 plus 6 gee vir jou 12. They are in series with one another, so it's as if they are together 12. Okay, so as jy dit gaan uitwerk, 6 plus 1 plus 3 is 10. Oor 12. Check my net. Dit gee vir jou 12 oor 10. I'm going to say this again. You have to show this part where you swap them around. Okay, waar jy dit ook sê. You can't just say equals to 12 over 10. That is not true. Jy moet daai deel wys. Okay, dit gee vir jou 1.2 ohm. How do you know you're more or less on the correct path? Because 1.2 is smaller than 2. Okay, now we can go and say, right, resistance is volts over current. The resistance is 1.2, the volts is 6, we want the current, and we get the current to be, I think, 5 amperes. Okay, so, wat ons nou hier uitgewerk het, is, in jou kop, jy het 5 mannetjies. You have 5 men, so that total current is 5 amperes walking through there. It's not true, there's not 5 electrons, want nou ampere is, current is a charge per time, so dit kan 1000 mannetjies wees in 200 secondes of wat ook al. Okay. So this 5 amperes does not mean 5 electrons. Good. Now they ask, what is the current through each branch? So of that 5, how much goes through there, how much goes through there, how much goes through there? Dis wat ons nou wil weet. Okay, let's look at one branch at a time. Okay, nou net vir vinniger gaan ek die formule klaar herrangskik. I'm going to rearrange the formula just to be quicker. Unati. For the 2 ohm branch, what is the volts? 6. And the resistance? It's a trick question. 2. Okay, so like we predicted, of the 5 amperes, 3 amperes goes through here. 3 ampere gaan daardeur. So die grootste chunk, 60%, gaan L kies. Then if we look at the 12 ohm branch, Brigitte, wat is die volts vir die 12 ohm tak? 6 in die weerstand? 12. And then you get 0.5 amperes. And it makes sense. Jy moet 'n halwe kop hê om 'n dubbel wiskunde moet kies, né? Goed, so the smallest fraction, die kleinste gedeelte gaan daardeur. And then kan Anela, without doing a calculation like this, what is the current through the 4 ohm? How do you get to 1.5? Yeah.
You subtracted the energy
Hmm?
You subtracted the 5 minus 0.5 is.
You said 5 minus 3 minus 0.5. Okay, because you don't want to lose a man halfway. So, almal moet weer by mekaar optel. Going.
As die geleide nie baie goeie geleide is nie, is dit tegnies moontlik om as te verloor en
Jy gaan dit verloor nie, maar dit gaan verlore gaan in die sin van die geleiers vat 'n bietjie, die ammeter vat 'n bietjie, maar julle doen dit nie op skool. Okay. Next one. Sê dan. Bereken die lesing op die ammeter, bla 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 bla. Ekskuus tog. Let's highlight. So hier gaan ons mannetjies do. We see that everyone must pass through there. Almal moet daardeur gaan. So that the total current passes through there. Dan tapelo. Into how many branches will our current split up? Into 1, 2, or 3? Choose, which one? Why 2 and 1 or 3? Okay, why does it not go through the voltmeter there? A voltmeter's resistance is too high. Okay, 'n voltmeter se weerstand is te hoog, jy kan nie deur hom gaan nie. So jy stroom split daar op en dan sien jy kom hulle weer hier by mekaar and you see everyone must pass through that ammeter, so that measures the total current. Okay, then you see you have 12 sandwiches for the day. If you plan for the day, you see you only have to attend 2 periods. Jy moet net 2 periodes bywoon. Jy moet doen Elwe, and then you have a choice between math lit or math. Okay, so jy het 'n keuse. So jy moet so toe gaan and then you have a choice. So you only have to split up your sandwiches into 2, not into 3. And whether you choose math lit or whether you choose math, you have the same sandwiches. So, Chichi, where do you predict the smaller current will go? Through the 6 or through the 3, and why? Where will the smaller current go? Why? The resistance is higher, and resistance and volts are inversely proportional to one another. Okay, goed. Soos dit nou ontleed, nou gaan ons die vrae kyk. Hulle sê vir jou, bereken die lesing op die ammeter. Where's the ammeter? There's it. It measures the total current. Okay, so we're splitting up our page into 3. Okay, the ammeter measures the total current. For that, we need the total volts and the total resistance. Bruce, wat is die totale volts? 12 volts. And Vanilla, what is the total resistance? Can I just say 4 plus 3 plus 6 gives me 13? Why not? Yes, so we first have to look at the parallel, add them together, and then add that to the series. Okay, so we have 1 over 3 plus 1 over 6. That gives you 3 over 6. Dink ek. Ja. Okay. Hoe weet jy is min of meer op die regte pad? Daai 2 ohms is kleiner as 3 ohms. Ja. Okay, but remember that is not a total resistance just yet, because that is only our resistance in parallel. We must still add that one in series. So die totale weerstand gaan wees 2 plus 4 gee vir jou 6 ohm. Okay, now we're going to get to the current. It's volts over resistance. Die volts is 12, die weerstand is 6 en dit geef my 2 ampere. Okay. Then I'll ask you, what is the volts of that 12 volts? How much goes to V1 and how much goes to V2? Okay, nou jy kan hierdie doen op 3 verskillende maniere. You can do it in 3 different ways. I quickly, for the first time, want to practice ratios in this. Ons het ratios al op ander maniere gedoen, but I want to do ratios here. Okay? So, what we're going to look at is we're going to compare this resistance with this resistance. Okay? So, this is 4 versus 2. Can you make mine? Okay? So, we have 4 versus 2. And with that, you're going to add them together, you get 6. So you have 4 over 6 and you have 2 over 6. Okay, of what? Of the total volts. The total volts was 12. Okay, so you get 8 volts here and you get 4 volts there. And it makes sense, it maak sin, want jy kry 8 plus 4 gee jou 12. But which one goes where? Which one gets 8 volts and which one gets 4 volts? Hierdie het ek vir jou gesê, is die eerste keer wat ek dit so doen. Here they do not swap around. What are we comparing here? We are comparing resistance with volts. We are comparing resistance. I'm going to look at this quickly. Versus volts. So from there you can see that resistance is directly proportional to volts. Want volts is bo die lyn. So it means the one that has the bigger resistance will have the bigger volts. Smaller resistance, smaller volts. So this is where they do not swap around. Okay, so hierso dit is die volts op V1 en dit is die volts op V2. Okay. And now we're going to look at where they swap around. Now they ask for the current through each branch. Die stroom deur elke tak. Daar's 'n tak en daar's 'n tak. Now you're going to say, right, 3 versus 6. Together that gives you 9. So you have 3 over 9 and you have 6 over 9. Of what? They ask for the current. So of the total current, which was 2 amperes. So you're going to say times 2. So I'm just going to highlight where I get this from. So that 2 I get from there. Right, en daar gee vir my 0,67 en hier gee my 1,33. Okay, and now I must remember, okay, what are we busy comparing? Resistance with current. Resistance with current. They are inversely proportional to one another. So R is omgekeerd evenredig aan stroom. Meaning the bigger current will go to the smaller resistance. So hier is wat jy gaan sê, dit is die stroom deur die 3 ohm en dit is die stroom deur die 6 ohm. Okay. They will, or yeah, you will need to depend on ratios more and more in grade 12. Okay, dan die laaste gedeelte hierso is eintlik iets wat ons al aangeraak het. But I just put it here in again. What is potential difference? If we look at it there, it's just your volts, your sandwiches. Here you can see you have 24 sandwiches, and the 24 sandwiches will split up. Okay, so daar 24 toebroodjies gaan opsplit. Okay, so ek gaan gou weer ratios hierso gebruik. I'm going to use ratios again here. You see there that we have 3 ohms and 9 ohms. So we have 3 versus 9. Saam gee dit vir jou 12. So you have 3 over 12 and you have 9 over 12. Of what? Our total sandwiches is 24 sandwiches. 24 toebroodjies. So hier het jy 6 toebroodjies. En hier het jy 18 toebroodjies. Okay, so Potomelu, the 6 volts, will it be on V2 or on V1? Say again? That's my question to you. Good. V1. And the other one is on V2. Why? Because resistance is directly proportional to volts. So the bigger the resistance, the bigger the volts. Kleiner die weerstand, hoe kleiner die volts.
En die ander ene is
Omgekeerd. Ja. Hoekom ruil hulle? Want hoe moeiliker dit is, hoe minder gaan daardeur. Ja. Alright. Then the last bit of grade 11 work. Die laaste bietjie graad 11 werk. Ja. Is the heating effect, die verhittingseffect. Now you did this in grade 9, if I remember correctly, as well. No, it's very easy. If something heats up, then we have a use for that. Why does it heat up? Because they collide. Hulle bots met mekaar. Nee, hoe meer hulle bots met mekaar, hoe meer hitte is daar en hoe meer energie gee dit uit. Okay, goed. Now, that is then linked in grade 11 to work, arbeid en drywing, power. Okay, so arbeid is work, driving is power. Okay. The definition here, not really the definition, but definition in brackets of work is the amount of energy transferred, the work done or energy transferred, ek kan nou net sê. Work done or energy transferred, en daar het jy hierdie 3 formules. Okay, those 3 formulas, you don't need to know how we get to them. Hulle is op jou datavel, they're on your data sheet, you just need to be able to use them. Normally this question counts 3 or 4 marks, meaning substitution, formula substitution answer. Dis nie 'n moeilike vraag hierdie nie. Okay, the difficult part is just to put in your correct values. Okay, so what is W there is the work in joules, arbeid in joules. V is potential difference, I is current, T is tyd, R is weerstand. And then your power definition there, that is a definition that they do ask a lot. Maar hy is ook in jou ander hoofstuk. Power is the rate at which energy is transferred. If you hear the word rate, tempo, waar dink jy? Divided by time. What must be divided by time? The work. So P is W over T. Okay, and there we have these 4 formulas. Again, it's not a difficult question. Jy gaan net moet dit kan gaan invul, and remember P is the power in watts. Ek het nog iets gesê. Okay. A question that they can ask, and they like to ask in a multiple choice type of question, is instead of asking the power, so hulle vra, how will the power compare? Hoe gaan die drywing vergelyk? They will ask, how will the brightness of the light bulbs compare? So jy moet weer 'n drywing en helderheid van gloeilampie is dieselfde goeders. Okay, but that's something that you subconsciously know. Het julle al gloeilampe gaan koop in julle lewe? I hope you all have bought a light bulb in your life. If you haven't, before you write science, go to Checkers or wherever. You just go look at, there's a million. It's not easy to buy a light bulb. There's a million cases. Okay? And then each one has a wattage on it. Okay, and dit sê vir jou hoe helder die gloeilampie gaan brand. It tells you the watts, tells you how bright the light bulb will shine. Okay, so gaan check net dit. Right, and then the last bit of grade 11 work, we're going to practice these formulas in a moment on the next page, is the cost of electricity. Die koste van elektrisiteit. Okay, now we buy units, units in South Africa, and this unit is in kilowatt hour. Kilowatt hour, dis jou unit wat jy koop. Okay, so how do you calculate this? It's 1,000 watts is 1 kilowatt times an hour. Okay, so if I tell you, you have, let's say you have a stove, and your stove is how many watts? Let's say your stove is 800 watts. And you use your stove for 90 minutes. And a unit in South Africa costs, it depends when you buy it, where you buy it, how you buy it. Let's say a unit costs R2.70. Okay. Right. Then I can ask you, okay, please go calculate how much it will cost for the stove to run for those 90 minutes. Okay, goed. So, dan moet jy weet, you must know, because this is not on your data sheet, any of these formulas. You must know that you must transfer or skakel om die watts na kilowatts. 800 watts is how many kilowatts? 0,8. Then you must know that 90 minutes you must man, waar's my woorde? Thank you. Convert to hours. 90 minute, hoeveel ure? 3 op 2 of 1,5 uur? Nee? Right. So to know how many units it will use, you're going to say 0.8 times 1.5. Because you want to get kilowatts an hour. So jy gaan die kilowatts maal met die uur. Wat gee dit vir 1.2? Nee, 1.2. 1.2 kilowatt a uur. So that is how many units. It's 1.2 units. And we want to know the cost. So dan gaan sê 1.2 maal met R2.70. Because it's R2.70 a unit. En daar kan ek nie my kop nie. Ek glo jou. R3.24.
Dis min. Yes.
Dis baie min.
Want jou stroom gaan definitief nie so.
Yeah. Alright. But they do ask a question like this. So you moet switch kan. Okay. Ek gaan gou vir julle 5 minute been rek kans gee, and then we're going to do these exam questions and then we're done.